Well, Andrew Bishop, hi there. How are you? Welcome to our Build Meets World broadcast.
Thanks.
How's Friday treating you so far?
Oh, not too shabby. It's sunny and clear weather here in California, so can't complain much about that.
That's
And
perfect.
before we get started, I have to say I truly appreciate the millennial nod to Boy Meets World. As someone who's technically a millennial, that's pretty awesome.
That's awesome. We've been doing Build Meets World for a couple years now, and we just thought it was just a great way to connect with people. And so now we just kind of, do just that. So I can't wait to get out there and visit you. I think it's interesting when I was Googling you, there is another Andrew Bishop at WJE. I should
There
have put,
is my alter ego with a structural background.
yeah.
We can
So this,
always tell when we're getting each other's emails. He gets an
I,
email about air water barrier continuity, and he's like, "What is that? This is probably yours."
that's
And
great.
someone sends me emails about cracked concrete on bridges, and I'm like, "You're looking for the other guy for sure."
Yeah. To be clear, this is West Coast Andrew J. Bishop, not to be confused with Drew Bishop out of the Northbrook office. So,
Exactly,
but
exactly.
they'll switch those emails around if you reach out to the wrong guy. No worries. So, perfect. So, well, thanks again for joining me today. This is something that we love being able to do, being able to engage with someone like yourself. I'm not there with you, so I put this together just to kind of demonstrate, our where we are in terms of geography, right? So I'm still in Cleveland. You're out there on the West Coast. Coming to you. I guess I'm live from Cleveland. You're live from Oakland or what?
Emeryville, Emery.
Emory.
Yeah, the little tiny city of Emeryville. For Pixar nerds, though, it's a very important little city.
It is. It definitely is. Do you guys scooter around the office there?
Actually, our former unit manager broke his foot and was on a scooter around the office for a long time.
My
So
brother
we
had one
gave
of
him a
those.
hard time about that.
Well, tell us a little bit about your background. I put some information up on screen about you.
So I thought at first the map you had up from Cleveland to Oakland, you were
Yeah,
like tracking my life journey, because I grew up about an hour from where you're at right now,
yeah.
um, and went and studied abroad for a year, but then ended up in Oregon, and now I'm down in California.
Yeah.
So you're from a broad perspective, you're tracking my life
Yeah.
there.
Your
Uh,
steps across. Yeah.
yeah, exactly. But I'm an architect by training. Went to a design school for undergrad, and got my master's in Oregon. And ended up down here in California, primarily because my first internship was here. And my brother was a grad student at UC Berkeley, and he was willing to let me sleep on his couch for free. And that was a great way to get started when you don't have a whole lot of cash to pay for California
Yeah.
rent.
Well, that's interesting. So you can associate your location to your brother. I'm the same. I was living in Olean, New York, and graduated from University of Buffalo. My sister lived in Cleveland, and she's like, "Why don't you come live with me and apply for jobs?" And here I still stay. So that's kind of interesting. Sharing spaces with our siblings brought us to where we're at
Exactly.
today.
Yep.
It's interesting to see, obviously your practice areas. I see a lot of synergies here with where we spend our time. So it's a no wonder that, we've engaged with you in the past, but it's a lot of great opportunities for us to engage and for you to engage, obviously, with the industry.
Totally, totally. Yeah, no, I appreciate you doing this.
Yeah. Well, and I love where you're sitting today, because the last time I saw you, I was with our colleague, Rich Block. So your contact up there, and it was November 18, 2019, before
The
everything,
before times.
the before everything seemed to shut down. Beautiful location. I love. My picture is a little bit askew to where your actual background is and your picture. So I think that's awesome there.
Yep, yeah, you were on the west side of the office. This is
Mhm.
this is the East Bay hills here behind me.
Beautiful location. So I appreciate that. Can't wait to make it out there to see you again very soon. But, as I reached out to you, it was we wanted to do, in the month of, gosh, what month is this? March. We wanted to walk through those requirements of an air barrier. And as you know, it's not like you're going to go to your ASTM guide spec like you do for other areas of our business, pull up air barrier requirements and start going through it, right? It's still somewhat of that wild west when we start to look at things. Now we do have a map, and the Air Barrier Association kind of gives us some guidance as well, but that's why we wanted to talk to people like yourself to get your perspective on those requirements of an air barrier. And we're going to kind of focus more in that continuity section today. But tell me a little bit about what you think about requirements and performance.
Gosh, well, continuous is a real tough one, and I think it points to why Tremco is trying to lead in this realm. Is that you guys as manufacturers of air barrier products and sealants, as well as the contractors who are installing this, they're often the problem solvers on the job site. You've got a window that you can't modify all that much. You got a roofing system that you can't modify all that much. How do you marry them together? It's the air barrier.
Yeah.
And, an air barrier can't be continuous all on its own. This isn't a balloon where you've got one product or, a data farm, a server farm with, no windows. We've got all these holes in our buildings because
Yeah.
people want to go in and out of them. People want to see in and out of them. Power and all of these utilities need to go in and out of them. So and all of that problem solving and kind of matchmaking, negotiating between different manufacturers and different products and subcontractors, that all that action really happens when you get to the sealants and the air barriers.
Yeah. It's so interesting. When I talk to people, it's like, like they're like, what do you do? And I'm like, those kitchens for all the stuff you see, right? They have to move, they have to, expand and contract, they have to handle weather, all the things that each of these regions that we build in and live in, it has to handle all that. So
Totally.
certainly a lofty responsibility for all of us when we come together. And we don't want to do this, right? We want to do this, when we bring those things together. So as we think about that, and think about all the different touch points, there's been a lot of work, as you know, as we look at our facades and just that evaluation. And I put it into these 6 little categories just to kind of help us with the discussion, because I think, tell me if I'm wrong, you and I probably talk about all this stuff for hours, right? So we have to somehow limit ourselves to this pocket of time.
No one's going to watch us for hours? Come on, Marcy.
I would think they would want to. So, but yeah, so somehow kind of direct us in our conversation, and kind of, kind of focus in this area, but of course we can expand beyond it. But so we're going to look at these 6 factors. So talk to me about exposure when we think of continuity and some of those impacts and things that you're looking at on a project.
Yeah, so exposure is a big one, and I think it's where a lot of people get into trouble. It's not just the exposure membranes are going to have in the finished construction. A lot of this is like partially completed construction. How waterproof and how robust is your air barrier and your other adjoining assemblies, and do you have them kind of in the right order of installation so that hey, in the middle of construction, you get a snowstorm. Not here in California, but we do some work in Alaska, and oh, it gets really cold, and that fluid applied membrane you just put on froze. What do you do? Or you get a big surprise rainstorm and your roof's not on. You got water trapped in the rough opening between your window and your sealants. Like, hey, was that thought through? There's a lot of exposure issues that I think designers don't think through. I think GCs and installers are kind of pretty aware of those issues, but it's getting the design and the installers to work together so that we've got good products that are going to stand up to that exposure. But some details that the geometry can actually be installed in a sensical order of operation, so that the sequencing isn't going to be a challenge if you have a rainstorm in the middle of construction.
I love all those points. Sequencing, that's a huge factor, right? When is something being installed, over what, who's installing it, how long are they waiting to install it, rainstorms, snowstorms. Yeah, there's
and procurement now. That's the latest and greatest. Can you actually get your material on site?
Yeah.
Or, did we get our air barrier up and our cladding is, 3 months out, or whatever it is.
Exactly. So you got to anticipate. And then I think the biggest thing is you just don't know what obstacle you're going to face. So that's where this kind of communication really makes a difference so that we know. And just like you said, problem solvers, right? I think majority of the calls we get is not just like, can you tell me the physical properties? It's like, okay, I put it up. Now what? I've got this challenge I'm facing. And I think that's why, as much as I think I know what's going on every day, I'm challenged with something new. So you're always learning. It's never boring, right? Never boring.
Totally, totally. Yeah, I think there's a big difference though. Like when you get a question of like, hey, can you send us your standard detail for XYZ? You ask a window manufacturer, or give us your standard detail. A lot of time it's just a window with nothing around it.
Yeah.
Whereas where your details are like, well, it could be this, it could be this, it could be this. Show us
Oh,
what your windows are. Show us what's going on right next to this.
yeah. Oh, for sure. And that is so critical, right? Because there is so many different things and the complication just continues all around that building enclosure. So yeah, understanding those limitations, installation practices, sequencing, and what kind of exposure we're going to see during construction is critical. And then in service, right? Because no one's going to go back and maintain any of these, right? They're unless it's a sealant in an exposed joint, you can't remove the facade. We can't just lift
Yep.
that up and start painting it. So lots of things to consider. What about fire resistance? What does that look like for the projects that you're on there on the West Coast?
Yeah, and NFPA 285 is, kind of the big touch point, that's always been around, but everyone's been talking about a lot more since Grenfell Tower,
Yeah.
when it went up in flames. But we've got wildfires to think about as well. This is a big one. Folks who are building, single family homes on remote sites are talking about this a lot more, and thinking about, okay, what part of my building am I willing to sacrifice
Yeah.
in a major wildfire event, and hardening our construction however we can. So there, yeah, this issue's, I think, more the more recent to the discussion,
Mm.
or at least gaining more and more attention. Um, but also generally from a fire standpoint, we're talking about wildfire smoke a lot more in California.
Okay.
Our energy code is a little behind the rest of the country. Most of the big urban centers here, air barriers aren't required.
Yeah.
But if you don't have an air barrier and there's wildfire smoke lasting for days on end, it's gonna not be real nice indoor air quality.
Yeah.
So I think folks are starting to kind of understand the importance of air barriers. Even when it's 70 degrees outside, you might still want to keep that outside air out if it's full of smoke.
Well, I'm so glad you brought that up because that is something to consider. Right? When we think of the continuity, right? If we're continuous, the thought process there is you're not going to have a gap or a void that's going to allow that natural the natural flow of air that's going to happen when we pressurize a building. So anything we can do to compartmentalize it, like we would when we're thinking of fire stopping, is so critical, even on your exterior of your envelope for all these reasons, and obviously for that, right? If smoke or whatever is out in that outside atmosphere, you don't want that to just get in. um, I was on a project once where I was talking to a consultant, and he said the staff kept getting sick on Tuesdays, and what we found out was that was the day that the semi trucks, kind of pulled up to unload their stuff, and they just left the engine, their truck engines running on
Yep,
Tuesday was the day that was getting into their airspace. So indoor air quality is definitely, obviously, even with the pandemic and thinking about all of that, continuity of that air barrier is something that can contribute to that. And it comes in many forms and fashions, and that's just, once again, a good reason to have a conversation. And the added benefit is that we can look at what that fire resistance looks like, once again, of the assembly, not that material or that sealant or that transition material, but how it all comes together.
totally. Yeah, no, and that's, I think, another way that everybody talking about air barriers and sealants need to be a team player. You're not
Yeah.
building the wall on your own. You've got insulation, you've got cladding, you've got support for that cladding. Do you want it to be a metal Z-girt or something, that's non-conductive that might be combustible?
Right.
You got to think about that, what you're willing to trade off, and what testing's already been done.
Yeah.
That if you're not building a new skyscraper, doing testing's pretty expensive to consider. So what kind of documentation and what kind of prior test reports does everybody have, and do all those reports jive together without having to, hire a fire protection engineer to do an engineering judgment for you?
Yeah,
Uh,
yeah, all those things so critical. And I think you stated before, like the installers and the general contractors, that level of awareness to know that if they change an anchor to something different, how does that impact? And I feel like the projects we're on, they've heard that and they're asking that question, like, well, wait a minute, that's not the same fastening mechanism that you guys approved. And so I'm always like, when they notice that and they ask that question, because it's like, oh my gosh, that's, we've come so far, right? In these last couple of years, to where we were before, where people are like, air barriers, I can skip that window, or like you said, it's not even required, right? In your area. So come a long way, and
we're
lots of our
getting there. We're getting
yeah,
there.
getting there. Yeah. The other thing I put in here is thickness. And the reason why I put that in there is, one, we can't maintain it, right? And it's going to be left exposed. So what do you think about the robustness or thickness of a membrane when
Oh
you're
yeah, this is huge.
yeah,
Especially for fluid applied. If you're doing this in, XOA Air 430, you're doing in a factory. You got nice, predictable indoor environment. There you can close the doors if there's a hurricane blowing through. If you're spraying this stuff on site, especially on taller buildings, and the wind is really kicking, it's harder to get the right mill thickness on the wall.
yeah,
And even in a test laboratory environment, we've
mm,
seen this come up with real thin membranes, where we got leakage coming through the wall. Let's check the fasteners, let's check the joints. And at this recent project we were looking at that was at the test lab, yeah, we were finding leaks at fasteners because the membrane wasn't real thick, so it wasn't
yeah,
gasketing around those fasteners. All right, do we need to start putting supplemental sealants? Do we need rubber shims? What are ideas there? But when we kept looking, we actually found water leaking through the middle of the air barrier. And we saw the same with air leakage. When we reversed the pressure in this test lab and started spraying soapy water in the middle of a panel, not at a
yeah,
panel joint, not at a fastener head, at anything, it was bubbling
uh,
because it was a really, really thin membrane. And gypsum is somewhat air permeable,
yeah,
and it was enough that we could blow bubbles through the middle of one of your competitors' products.
yeah. We've seen that, in our test lab when we're looking at different things, right? Just, like, hey, what if you go this thin? What kind of impact? What does this fastener do? What does this substrate do? And it can be pretty intense. And when you think about, depending on your construction and where you're building, right? The higher you go up, that's going to impact it even more, right? So it's lots of things to consider. I'll tell you something. Some of these installers, though, that apply the fluid in the field, I mean, so many of the guys I work with, they'll just put it up and they'll go, it's 70. And it is. And it's like, you guys are amazing. Like, because
Yeah.
they do it. And they always call me the theoretical installer. They're like, how much square footage have you covered? And I'm like, you got me on that. You got me. So I always want to do a shout out to those guys, because I'm always impressed with their ability to understand that viscosity, that hold, that substrate, and they're the ones calling me going, this is getting sucked into that substrate, what's going on here? And
Yep.
they're certainly a super valuable part of the team, that's for sure.
Yeah, totally. When you've got a good installer, when you go on site and you ask, "Hey, where's your wet film gauge?" And they have it, and it's filthy dirty, and they
Yeah,
know how to use it,
yeah,
but they already intuitively know how thick it is. And
yeah,
on the other end of the spectrum, you get the installer who goes, "What's a wet film gauge?"
yeah,
Then you're like, "Uh-oh."
yeah. What's a
Uh,
mill? Uh-oh.
Exactly. Let's pay some more attention here. Make sure we've got the right partner here on the project.
Exactly. So what about compatibility as we talk about all these things coming together?
Yeah, this is a tough one. There's a lot there. We've seen compatibility issues pop up in a couple regards. The most recent one I can think of was an incompatible sealant that wasn't actually touching. It was just near another sealant that was curing, that was off gassing, that kept that other sealant from ever curing. It just stayed a tacky mess. Others, are there plasticizers in the materials that are going to migrate, and suddenly something that was well cured suddenly liquefies and starts running off your building? Or, is it temperature, compatible with the expected temperature? Is it a high temperature material? Even if there's no chemical compatibility going on, is there a temperature problem where something could melt? Or is there a compatibility problem that just causes discoloration?
Hmm.
Some of these compatibilities are aesthetic
Yeah.
problems. Okay, is this an exposed sealant? Is this going to cause long-term problems? Or is this just going to not look nice? So yeah, it's important to kind of understand all of the different compatibility problems. There's no sort of checkbox on the data sheet. Yes, this is compatible. I
Yeah.
wish it were that simple, because there'd need to
I
be
wish,
probably
right?
50 checkboxes.
Yeah. But I think that goes back to, once again, communication, collaboration, and working together, because I've said it before. I mean, I would like it if it was all ours, everything. I wish I was responsible for everything.
Totally. And I wish I got to draw everything too.
Right?
That
I mean,
would be great.
yeah,
I drew every detail,
yeah,
and I know what products they're going to be. That's, yeah.
exactly. So,
None of us have that much
no,
control in life or in construction. So we
yeah,
all need to be good communicators and team players.
absolutely. And definitely something we need to consider, whether it's touching or not, because those
Yeah,
can be factors. And adhesion, of course, right? Our beloved, when we think of continuity, we want that whatever it is, sealant, transition material, or air barrier membrane to stay adhered, right? So talk to me about adhesion.
totally. Yeah, adhesion. Sort of once you pass the compatibility hurdle, you got it to stick. Now, is it going to stay stuck? Or, oh, it cured, but no, that's not really stuck. You can peel that off pretty easily. Especially at rough openings, polyethylene facers on a lot of self-adhered membranes. That's a tough one to stick to. I'm seeing other plastics that are tough to stick to.
Hmm.
Air barriers, you sort of think of them as saran wrap. You have your real complex building, and you need to saran wrap it with an air barrier, and that means it's got to touch everything that's there.
Yeah.
Stainless steel, that's also a slicker surface, a little hard to stick to.
Yep.
So when doing some adhesion testing in your lab, which I know you guys do, that's a great thing. You can send your substrate samples and get some assurance before you're standing out there in the field trying to get it to work.
Right.
It's a lot easier if you know ahead of time. Oh, this is a tough material. This one will need a primer. This one's no problem. We'll stick to it any time of the day. Um, Moisture, that can certainly affect adhesion. Okay, there's a little bit of moisture. We get a lot of morning fog and dew around here. How dry does it need to be dry to really stick to it?
Right. Yep.
That's, some good field testing is helpful, when you're doing your mock-ups, to get everybody tuned in to all those variables on the job site that can affect adhesion.
Yeah. Excellent points. Because yeah, there. I mean, obviously, as a manufacturer, we're going to do all we can before it shows up on the job site, which is all these pictures mimicked here. But that's just to show you that, hey, here might be a concern in standard conditions, right? So if you're
Exactly.
not building in 70 degrees and 50% relative humidity, let's field test it as well and see what things we might need to do in terms of cleaning or priming. And dry to the touch, or dry within that substrate, moisture content. Oh my, not to
Totally. Totally.
quite a horror story of sorts, but it certainly keeps us communicating, right? So that we can sort out what's going on, and be that investigator of sorts to see what we need to
Yep.
address. But great
Yeah.
conversation there.
Oh, but the other adhesion though is then you're going to stick something to your air barrier sometimes.
A-
for an ESAP
abs-
application, I know there's,
Absolutely. What's it's sequencing, right?
yep,
Right? So you have to know what you're adhering to and what might be adhering to it. So yeah, there's so many things. And that's why there's multiple samples, right? Because is the coating first or is the sealant first or is the air barrier first? And then, what condition do I need to test it in and in what order? And it turns into a big thing. And maybe that's why, like, my niece has been an intern, my son has been an intern, my daughter has been an intern. None of them work for us. They all went to other areas, but they found it exciting. And they did say everyone they worked with was pretty passionate about what they did. So if this is your passion, find your passion and go after it.
totally, totally.
And that's actually where I started my career because I loved material science. So I got hired in the 90s to do just that, look at adhesion and compatibility of everything we could get our hands on. So lots of great experience then. And then you can throw in all the volatile content restrictions and the complications that came after that, which could probably be another conversation. So
Oh, yeah.
our last bit of continuity, or I guess connectivity, I just wanted to put this up here to do a shout out to the Air Barrier Association of America. They just were here in Cleveland and they did a series of tests. They're looking at a different type of fastener research project. So we were really happy to support them. And you can see a bunch of those folks there. So stay tuned from the Air Barrier Association of America. I know they'll be sharing a lot. Their work in conjunction with their co-chairs, Andrew Dunlap, Sarah Flock, and of course, Oak Ridge National Labs. But I thought it would be interesting to bring up this because I know this was a study that you did here in Cleveland with a lot of different players. I highlighted obviously the group picture there, but also James Strong there from WJE, and then our buddy there, Bill Cardo, who lives in the Pacific Northwest as part of the team of
Yeah,
what
he
you.
knows a thing or two about wet substrates.
Yes,
You've
right.
got
So
2 hour window to work in.
yeah, we learned early on that when we were looking at innovative approaches to different applications and solutions, we couldn't just talk to Texas, we couldn't just talk to Boston, we couldn't just talk to Florida. Like you have to talk to all different regions and understand what those conditions are for sure.
Totally, totally.
Everything. I mean,
Yeah, no, and this was a great project to partner with Tremco on. It was we were, dealing with stucco and building papers, because a lot of construction here in California doesn't have an air barrier.
yeah,
But we were looking at, okay, how can we improve that? Can we improve it with, fluid applied flashings at windows? Can we do,
yeah,
do fluid applied, flashings at penetrations? And we were looking at how did those compare to each other? And we were able to create a lot of good leaks. Some of them intentional, some of them not so intentional during that testing. But the one I was really amazed by was that we had no window perimeter leaks. Where we were using Tremco's fluid applied flashings, either with their air barriers or partnering it with building paper. That kind of blew my mind. I was assuming like, oh yeah, we'll probably have tons of window perimeter problems,
yeah.
but we had zero. Yeah, kind of blew my mind how much you can improve just real basic wall assembly with some better flashings.
And that's what I think was so interesting when we think of like connectivity or continuity and connections. It plays such a critical role. And I think, even though we have seen, you and I both, and many people have seen areas in the issues with the opaque walls, which is concerning, but what can we do to make sure we get that good flashing material in there, right? And I think that was a great outcome of what you guys worked on, in addition to the learnings from this whole study. I included this picture for two reasons. I loved that you guys tested by stage, right? So you know what I mean? Like at each stage, you learned something about your assembly versus the whole assembly, right? And then we also, when we look at stuff, the air barrier might be tested on its own, but do we start to include the fasteners, and do we start to include the facade and the window, the real window? Those are
Yep.
all things that are, people might not realize when you look at a certain test, it's just a wood buck window and no facade. So I love that you guys went through those stages. And of course, you're in there investigating closely on the front of that wall. So I had to include this picture.
Yeah, no, it was great because a lot of the questions come up around here of like, oh, well, is the stucco part of the water management system? It's like, oh, we're testing this without the stucco
Yeah.
installed. Can
Yeah.
you even get a test like that to pass?
Yeah.
And I think, yeah, we proved, yeah, you can, and you can You can subject it to some rough abuse and water exposure, and still learn a lot. Well, before you cover everything with stucco, it's cheaper and easier to fix things. You can find some of your problems.
Absolutely.
But we also found that some of the leaks would show up before the stucco was installed. And once you put the stucco on, it would hide some of those problems. But then other new ones would show up
Yeah.
where the stucco was creating a little dam that water would kind of build up behind. Water would come in through that spot where it wasn't coming in before. So I think it helped kind of prove that field testing is not easy.
Yeah.
It's very nuanced, and you need to know what problems you're looking for before you decide how you're going to test to find whether you have that problem or not.
Well, and I think that's what was so great about working all together. And obviously, this is something that we enjoy doing. So, we've done a lot since this was back in, I think, 2016 or
Yeah,
2017. So done a lot since then. So lots that we can share, and obviously opportunities for us to work together on new assemblies. But I think that's what's so interesting because, do you test with that facade or do you test without the facade? Does the facade give you a level of protection or does the facade hide what's going on? And how long should you test so that the issue can show up on the backside of the wall and so that you
yep,
can address it, or will it ever be that severe of a situation that you would even have that type of a leak? But to me, it's always, if you can take that time to do an extreme test, it still just educates you on how
yep,
important the detailing is and getting it right. Because once again, we can't tear it apart to fix it later. So
exactly,
all of
exactly.
those factors are a huge part of it. So I know there's lots of great information that can be found. I know you've given this presentation and would probably be willing to give it again if we found the need from our audience today. And then also a shout out to one of the partners that worked on this, Jason Wigboldy, with Rodent House, now True Fast. So he wrote an article that is in Walls and Ceilings. And so I think that destructive picture down on the bottom right is a good reminder that that was exactly what you guys were able to do. You could force the leak so you could learn from it, but then you could also rip it all apart to find out where it was leaking, where you weren't anticipating it to happen. So lots of great information that can be found there. And I just kind of wrapping us up today from a continuity perspective. There's so many things I think that we need to look at from that connections of those transitions. And then of course, all over that building envelope. So these are just a few final little ASTM nuggets I like to share on things that we do and things we can collaborate with. But any final thoughts you have for everybody today as it relates to all of this?
Yeah, I guess continuous. This could go on forever, and it's what is hard to do with an air barrier. You can't wrap your windows and doors in air barrier material. You gotta think through all those transitions, and you need a manufacturer and an installer partner that's going to be willing to run through all of those transitions and details with you. It's really important to build a good team to actually ever get continuity.
Yeah. Well, I know there's going to be lots of good questions. And there's lots of follow up. I'm sure we're going to be able to do. So I'm hoping you'll join me again in the future, maybe on part 2 of air barrier requirements, and maybe even in a panel setting. Not to put you on the spot, but I love the chance to talk with you. Hopefully, we can do it live and in person soon. Um, but yeah, thanks.
Totally.
Thanks for being a part of us today.
Thanks for having me. Have a happy Friday.
Yes, you too. So more resources, more video of Andrew Bishop in action here at our test facility if you're interested in catching that. And of course, as always, you can reach me directly at mtyler@tremcocpg.live if you would like to join in on the conversation.